Hey there, and good morning, and thanks for tuning in here to my session at Global Azure Austria. My name is Thorsten, and I want to demonstrate you the latest addition to Microsoft's serverless capabilities. That's called Azure Container Apps. And without further ado, let's jump right into it. So, yeah, as I said, my name is Thorsten Hans. I work as a consultant with ThinkTecture in Germany, and I mainly focus on cloud native, which means in our terms, if we speak about public cloud, it's Azure only, because we have strong history in .NET for more than 2 decades right now. And yeah, besides cloud native, I obviously do a bunch of stuff in Kubernetes, Docker, and also infrastructure as code is one of the things that always got my attention. So the most important thing on this slide, obviously, is my mail address and my Twitter handle. So if you have any question, don't hesitate, just ask. And so we can take it from there. Okay, so in the upcoming 50 minutes, we want to dive into Azure Container Apps, what it is, why we need something like Azure Container Apps, how we can provision the service itself, how we can deploy apps to the service. And then we take a look at monitoring, running different patterns, let's say it that way, or application shapes in Azure Container Apps. And last but not least, we take a look at inner loop deployments, how we can, get something up and running in Azure Container Apps in almost no time. All right. So obviously, the first question that always comes into my mind when Microsoft releases a new service and adds it to the Azure surface, then it's, do we really need that service? And especially for containers, this question is valid because there are plenty of options to run containers in Azure. But the short answer to this question is yes, we do. So why do we need another service in Azure where we can throw our containers in and get them executed? So obviously we have Azure Kubernetes service, right? Which is the rock star that when it comes to running containers in Azure. However, AKS brings capabilities like auto scaling on the level of the cluster, which makes it elastic. Although that's a great feature, it's not serverless pricing, right? We have to pay in advance for the compute power we allocate. So this is one of the reasons why we need a serverless capability. Obviously, Kubernetes could become really complex depending on the architecture of your application and depending on the dependencies that you need to actually make your application work as you want it to. And one thing that we recognized over the past years is that finding, hiring, and keeping people that know Kubernetes is really, really hard. So if you're the lucky one who was able to find someone, it's really, really hard to keep him over a longer distance. And yeah, so from the projects that I was involved with in the past, let's say 4 to 5 years, that leverage Azure Kubernetes service, it was sometimes an overkill. So I found Kubernetes being deployed in several organizations just to check the box and say, okay, we are using Kubernetes. So maybe it's worth taking one step back and saying, okay, what do I really need to run my application? So, and these are reasons why Azure Container Apps is a great addition to the overall service landscape that we can leverage in Azure to run containers. So speaking about the landscape, we have several services that we can use to run our containerized workloads. And this is not a complete landscape. It's just showing those services that we use to run general compute workloads like web APIs, microservices-based architectures, stuff like that. So obviously there's Azure Web Apps for containers, like a subset or a special edition of the Azure App Service, which is technically Microsoft uses a reverse proxy listening on port 80, port 443, and proxying requests to a container being executed in the service and just serving your workloads. So this is great, a great service if you have experience with Azure App Service, how to run them, how to maintain them, how to troubleshoot them. Then you can just use a Linux app service plan and deploy your Linux containers into Azure Web Apps for Containers. Or if you have to use Windows containers, then you can do the same with a Windows-based app service plan. So this is available for years right now, and there are several use cases where Azure Web Apps for Containers definitely makes sense. Then we have Azure Container Instances, the up until now called serverless story for running containers in Azure. Although it is powerful, right? We can orchestrate several containers that can talk to each other. We can configure ingress to route requests over the internet into a container and stuff like that. There are several patterns where, at least in my opinion, Azure Container Instances make sense. That's, for example, a burst mode where you have to do heavy processing on a certain point in time. However, the process itself should not be that time critical, because from my experiences, Azure Container Instances sometimes need some time to pull images, especially if you're using Windows containers. Then it could take up to 10 to 15 minutes until a container gets pulled to Azure Container Instances before it's actually starting. So keep that in mind if you think about using Azure Container Instance. A great service because you can spin up hundreds of containers in a certain amount of time. However, if the process itself is time critical, maybe other services are a little bit better, a better fit. And Azure Kubernetes Service, as I said, the rockstar, powerful managed service offering that gives you full-fledged Kubernetes where you can, just add extensions. Extensions are like small additions that are managed and provided by Microsoft. Like, for example, if you want to use GitOps, or if you want to use Dapper, then you can just, upon provisioning the cluster, you can just say, hey, I want that, tick the boxes, and Microsoft will deploy everything for you. And they take care about, running, maintaining, hardening the Kubernetes control plane. And this was actually, the state of art. And we were using Kubernetes for years right now in Azure. However, talking to so many developers about Azure Kubernetes Service, we and also Microsoft recognize that the complexity that Kubernetes adds on top of everything we have to deal with as developers is too much especially for smaller teams, right? So with that, Microsoft came up with Azure Container Apps in October 2021. That's when the preview started. And it's basically an abstraction layer on top of Kubernetes, allowing us to run several containerized architectures and have a serverless pricing model. So with that, that's the new landscape when it comes to running containers for general compute in Azure right now. So let's dive into container apps. It's serverless, yes, and we will be charged only on the actual consumption. So there is no upfront payment required. If you run your container for, let's say, 24/7 in a 24/7 mode, then you will be charged for the allocation of memory and CPUs multiplied by the amount of time. So that's a pretty good pricing model. I think, if I remember correctly, the amount of requests is also playing a role when it comes to pricing. But yeah, it's already public in the Azure pricing calculator. Go check it out. Obviously, you have to do the math in order to get a rough estimation on where you will land with when you use Azure Container Apps to run your services. It's the good thing about Azure Container Apps. It's not homegrown. I mean, it's not, built from scratch with any proprietary libraries or stuff like that. It's built on top of powerful and well-known open source projects in the container sphere, or let's say that are, I think all of them are right now under the umbrella of the Cloud Native Computing Foundation. So there's Kubernetes, obviously, building the foundation. Then there's Envoy, which is a network proxy taking care about all the things, traffic routing and stuff like that. There's Dapper that we can use to build microservices, KEDA that we can use to scale certain parts of our application, like one container, depending on contextual load. We will look into those a little bit deeper in a second. But basically, those 4 open source projects, they build, the basement that gives us the possibility to get rid of a lot of plumbing. So we don't have to care about, maintaining Dapper or installing Dapper in the cluster. We don't get any kind of cluster access with Azure Container Apps. So that's one of the most important goals. It is, an abstraction layer on top of Kubernetes, hiding complexity and allowing us to provision our apps quicker or faster, however, still using the benefits that a powerful application runtime or platform like Kubernetes provides us. Which leads to the question, okay, which kinds of apps can I run in Azure Container Apps? Right now, Azure Container Apps is Linux only, so you can only run Linux containers in Azure Container Apps as of today. Underlying AKS is x64-based architecture, so there is no ARM support yet, but I think there is a work item in the public AKS roadmap that should address ARM, and maybe we get ARM in Azure Container Apps at some point in time, but for now it's Linux-based containers on the x64 architecture. So having Linux containers, we can obviously, if you build a Blazor front end, a web API, and you use, let's say, SQL Azure as a data storage, then you can obviously just deploy that 3-tier architecture to Azure, where the database is, using PaaS offering, and both the Blazor application and the web API, like front end, back end, will be deployed to Azure Container Apps. On top of that, you could deploy any kind of microservices-based application or architectural approach in Azure Container Apps. You can do event-driven applications. That's where KEDA comes into the story. And there is right now a story how you can do background processing, like, for example, the cron job that runs every night or so. That's also based on KEDA. However, my personal opinion is that background processing needs to, mature, or, it needs some love from my point of view. So Kubernetes has a more robust capabilities to run cron jobs or jobs in general. Maybe Azure Container Apps team will adopt those during the preview, but at least we can somehow, get background processing up and running in Azure Container Apps. Okay, so I said it's an abstraction on top of Kubernetes, taking away a lot of the complexity. So what do we have to deal with, right? What are the building blocks? So an Azure Container App always belongs to one Azure Container App environment. So you can think about the environment as a logical barrier, right? Where we can deploy multiple apps to. An app could be deployed in a single revision, so there's just one version at a single point in time, or we can use a multi-revision mode where we have like the current version and the preview version of, let's say, the Blazor app running in Azure Container Apps. So we deploy our apps into an environment. Those apps in an environment can talk to each other without, going over the public internet or over the Azure WAN. And every container app consists of a pod. A pod is a concept that is introduced or has been introduced by Kubernetes. And a pod is basically a collection of containers executed on the same virtual host, which allows us to do to implement sidecar patterns. So think about having you're doing a lift and shift. You take your .NET API, migrated it to the new .NET so that you can containerize it, and leverage Linux containers. However, you are still logging to the file system, right? Which is an anti-pattern when it comes to containerization. So you could take another small container and run it in the same pod. So they both run on the same virtual host, and the small so-called sidecar container is just responsible for watching the log file, reading everything, and piping it to standard out so that other systems in Kubernetes or in Azure Container Apps are able to take those logs from standard out and forward them to a log aggregation system. So pod is an essential concept of Kubernetes, which adds other capabilities, right? Like health probes and stuff like that. And we reuse that concept in Azure Container Apps too. During the preview, or at least as of today, there is a limitation that you're allowed to have 2 Azure Container App environments per Azure subscription. And this is definitely a preview limitation. So the team is working on, removing that limit. But for now, keep in mind that you are only allowed to have 2 environments per subscription. All right, so let's talk quickly about the building blocks of Azure Container Apps. I mean, Kubernetes, there has been millions of talks about Kubernetes, and there will be millions of talks about Kubernetes. So I just want to revisit the other, pillars that are used to bring Azure Container Apps alive. And first is Envoy Proxy, which allows us to, for example, define ingress rules so that we can, allow requests from the internet or from a virtual network environment going into a certain container. In Envoy also takes care about several things like traffic split. So that's the first SMI spec item that has been implemented by the team. So if we have 2 versions of our front end, we can say, hey, route 90% of the traffic to the stable version and 10% of the requests towards the preview version. When you have multiple containers running in an environment, those apps can talk to each other via HTTP, via gRPC, so they can resolve, the DNS name of the other container app, and if you have experience with Kubernetes, you can think about this capability as using the full qualified service name of another service in Kubernetes. And for reference, there's just one sample on this slide. So Envoy takes care about, dealing with requests, routing them to particular containers, and we have simple and only a few configuration opportunities to make Envoy work as we want it to. Dapr. So Dapr is built or is deployed into the underlying Kubernetes cluster. Let's say it that way. We can use Dapr to build our microservices, but we don't have to. It's 100% optional. If you use Dapr to build your microservices, then you don't have to care about, running the sidecars or annotating your containers or anything, right? We just say, hey, we want Dapr, and we say, okay, these are our components, our Dapr components, and everything else is managed by the service, so we don't have to care about it. Again, because it's really important, Dapr is 100% optional in Azure Container Apps. Last but not least, there is GAA, which is Kubernetes event-driven applications. And the cool thing is, Kubernetes, for example, has horizontal port autoscaler, which allows us to scale certain containers horizontally based on the actual resource utilization, like, for example, CPU consumption or memory utilization, right? GAA takes this approach one step further, and it allows you to use, for example, Azure Service Bus or a Redis cache or whatever. There are like roughly about 40 so-called scalers that we can use as a scaling metric, right? So, for example, you say, hey, there is a queue in Azure Service Bus. If the queue has more than 100 messages waiting to get processed, then please scale from 1 worker up to 10, right? And so GAA is able, to understand those metrics. You provide thresholds, and then GAA will scale in those boundaries. So GAA is great when it comes to scaling within a distributed application architecture. Okay, with that, enough for the slides for now. Let's jump right into VS Code. So I have several samples prepared for today, but first I want to get you through, okay, how can I get started, right? So obviously so the portal experience is maturing over the preview phase right now. So it's way more powerful today as it was like 3 weeks ago or so. But I love my terminal, and there's Azure CLI, which allows us to, script everything, to automate it. So that's a good starting point, at least for me. So there is an extension for the Azure CLI that you have to install in order to use those commands, to deploy or to create a container app environment and so on and so forth. So that must be installed on your machine. Then we have to register 2 namespaces. Although Azure Container Apps, as of today, is living in the namespace Microsoft.app, it was historically built in Microsoft.web. That's why we need to register both, just to be on the safe side, right? So there is a migration ongoing right now that migrates existing Azure Container Apps from Microsoft.web towards Microsoft.app. However, I'm not 100% sure if that migration has finished. So to be on the safe side, just register both. So with that, we have everything in place, right? So we can, play the regular Azure game, right? Obviously, we need a resource group, and we need to decide to which region our services should go to. Azure Container Apps is not available in all regions right now. There's Canada, there's East US, there's North Europe. At least those are the three that I know. Maybe there are more, but you have to check if Azure Container Apps is available in your desired region. Okay, so right here, setting some variables like names and the container image that I want to run. So we create a resource group. Within that resource group, we create a log analytics workspace. We will take a look into that later. Then we create an Azure Container App environment, link that to the log analytics workspace. And having that container app environment, we can just throw a container over the wall. So for example, I say, hey, create a container app with the name Hello Akka in the resource group in that environment using that Docker image. And by the way, that image is exposing something on port 80. And I want to route requests from the internet onto that container. So I set the ingress to allow external requests flowing through the network infrastructure into my container. Last but not least, I query for the full qualified domain name so that we can, access our first application. So let's just invoke that. Nope, let's go to the right folder first, and let's invoke the deploy. So that should take a minute. We will see, okay, it's validating that the extension is installed and updated. Oh, there is an update. Great. There was no update half an hour ago, so fingers crossed, hoping that the update won't break the demos. All right, so right now it's registering the namespace, the providers. That should be quickly done. Then the resource group is created. Log analytics workspace should be created in a few seconds. There we go. Now it's setting up the container app environment. And with that being processing, we can move on to, to the Azure portal. Let's go to resource groups. And let's do a quick refresh over here. That's heavy caching. There it is. Hello, Akka. And we see already, okay, there's the container app environment, there's the log analytics workspace. Let's browse the container app environment. As I said, it's preview. I can imagine that there will be plenty of more blades available once we hit a GA with Azure Container Apps. For now, we just have the list of apps, being deployed to that particular environment. So I think that needs another second or two. Yeah, there it is. Let's quickly jump back to VS Code to see, container app has been created, so we can go to the blade, to the resource and see what's happening over here. Most important thing, we get the full qualified domain name here too, so we can just paste it, and we see the Gopher cheering at us for spinning up our first application, Azure Container Apps. And to get an idea of what's possible right now in Azure Container Apps, you see, okay, we can deal with authentication. So they announced Easy Auth support a week or two ago. We can, for now, fundamentally deal with secrets. We can control the ingress. That's what we already did there. We can also bring in VNet support over here. We can configure continuous deployment. We can have a single or multiple revisions. We can inspect our containers to see, okay, it's running the following image with the tag hero, and it's leveraging .5 CPU cores with 1 gig of memory. That's customizable, by the way, but it's just a default value. We have no custom environment variables specified. So right here, for now, we don't see all the environment variables. We just see those that were specified upon deployment. We can scale it. I don't think any scaling is needed for now. So keep that as this, and we get metrics and logs, but we will look into that. So spinning up a single container application in Azure Container Apps is fairly simple, right? But typically containerized applications consist of more than just one container, and we must take care about other important aspects, right? So we must take care about how can we provision it. I mean, Azure CLI is great experience for the inner loop to try something, to get something up and running quickly, but somehow we must address, infrastructure as code, for example, and the story. So the entire abstraction that Azure Container Apps gives us is built into Azure's ARM API, which means we can and we should, at least now, use Bicep to provision the service, to deploy our apps, to do everything, right? Because that's the first-class citizen, right? We can directly talk to the ARM API. Speaking about ARM API, speaking about infrastructure as code, Polumi, an alternative to Project Bicep, they already have a story how to deploy Azure Container Apps with Polumi. Terraform does not support container apps yet. The progress of the implementation is tracked in the issue that's linked in the slides over here. So we've seen how to, do it with Azure CLI. We know Bicep is great. So there's one thing missing. We must talk about the images, right? We can obviously consume public images from any kind of public registry. So you can also configure your ACR to allow anonymous pulls. Then you don't have to deal with any kind of sensitive data. However, if you use a protected container registry, or you want to pull an image that needs authentication, you must provide the credentials for now, also when you use Azure Container Registry. Today, there's no support for using a managed service identity to pull images from Azure Container Registry. That's a highly requested feature, and I hope, and I know for sure that the team is taking care about that, but it's not yet there. So right now, you have to provide the credentials as part of your deployment, right? The good thing is all the tools gives us capabilities to deal with sensitive values like tokens. And if you are, by the way, using Azure Container Registry, please do not enable the admin account to deploy your containerized application. Please consider going for the premium SKU and leveraging scope maps, which is kind of permissions inside of ACR. And then you can create tokens, which is basically a combination of an identifier and a password for that particular scope. So that means you can pull it also from the outside of Azure, and you don't have to create anything inside of Azure AD or so. All right. That's enough stuff for another demo, right? Or for more demos. First, let's take a look again at, let me quickly destroy, because otherwise I hit the limit of having two container app environments. So how can we deploy a container app with Bicep? So there are two important entities that we need to know. There is the managed environment, which is the Azure Container App environment. And as you saw earlier in Azure CLI, the configuration is pretty simple, right? We give it a name, we give it a location, so the Azure region, and we say, that is my log analytics workspace where I want you to push logs to, right? That's it. So that entity is fairly simple. The second one, that's the interesting one, right? That's the abstraction. What do we need to write to run a container inside of an Azure Container App environment? So there's a bunch of, configuration plumbing in that file, but basically we have to create an instance of the container apps resource. again, we have a name, we have a location, we have to link it to our container app environment. Then we can, that's optionally, specify how ingress should be configured for that particular container app. In our case, or me, I have, just created a Boolean parameter and a Boolean port and a port parameter that allows me to quickly configure that container app from outside by leveraging bicep modules. And here you can link it, for example, to custom domains. Oh, that's great. That was not there. I was surprised right now. I did not saw it a couple of days ago. Great. But then you can, for example, configure if you want to use HTTP2 or not. And I think over here we can also, configure if you want to use protected container registries or stuff like that. But that's totally optional. What we really need to define is the container. So remembering, we use pods. Pods can have multiple containers. That's why we have to provide an array of containers. Every container consists of an image. We have to give it a name in order to, identify it if there are multiple containers. And we can provide environment variables, and we will see more capabilities popping up right here, like, for example, mapping volumes and stuff like that, because the team is currently working on bringing support for volumes. We can define health probes and stuff like that, but that's the minimum. And last but not least, we can control how that particular container should be scaled. So there should be a minimum instance of 1, and it should scale up to 10, for example, right? Then we can further control the scaling behavior. Should it use CPU-based scaling? Should it use memory-based or memory utilization-based scaling? Or should it leverage another scaler provided by KEDA to scale on, let's say, an Azure Service Bus queue? But that's it. Nothing more needed. So there's plumbing in that bicep, right? Log Analytics workspace, definitely a cool service, but yeah, not in the scope for this talk. And then there's the main file, just linking together those modules. So it's just, defining the overall, variables or parameters, and then configuring the 3 upstream modules. Okay. With that said, there's again a deploy, and the deploy does nothing else than creating. Let me quickly hit deploy so we don't have to wait that long. Dash deploy. So it's creating the resource group, and then it's just using the regular deployment interface provided from Azure CLI to start a deployment leveraging Bicep. Obviously, you can also use Bicep CLI. Yeah. So this one should also be up in a second. And maybe you have recognized, so there is a Paint. That's basically open source project or fork that a coworker of mine, Christian Liebel, is maintaining. That is the traditional Paint that we all know from the early days of Windows being implemented as a PWA, leveraging all the great PWA capabilities. So we hope to see Paint deployed in Azure Container Apps in a second. There is the container app environment. Oh, I have to refactor the name. That's a bit misleading, right? Let's dive into the container app environment, and yeah, it needs another second or so. Let's hit refresh one time. Oops, here I am again. Sorry for that. There was my... So you should see my screen again. No, just give me a sec. Just messed it up. Ah, damn. Okay, so right now you should see my screen. Sorry for the hassle. I hit refresh and the wrong window was focused. Okay, so there we go. Paint is deployed. Let's quickly open up Paint, paste it over here, and we can, do our best to draw nice pictures and use the Paint implementation in the web. Okay, cool. So we saw so far 2 single container apps. I have already deployed the next sample, which is a multi-container application. And I've deployed it because it's leveraging Azure Cosmos DB under the hoods to store or to persist data. And provisioning Cosmos DB takes some time. But basically, it's the same pattern, right? We have our apps. We look into those. We have a bicep file specifying it. And you already see there's a dapper.bicep, which, configures Cosmos DB as a state backend. So in this example, I have a multi-container architecture. I don't want to call it microservices architecture. That's leveraging Dapper. So I don't need to take care about implementing, persisting, or reading state. So there's a facade that's written in Go. Let's quickly revisit this one. That's basically acting as a proxy, right? There's a request hitting the facade. The facade uses Dapper service invocation and says, "Hey Dapper, please invoke the following method that's provided to the facade," just forwarding it to something that's defined by, or that Dapper should know by the name order API, or for example, inventory API. So Dapper is taking care of taking that request, identifying it, and saying, "Oh, that's order API. That's for container XYZ." Okay. On top of that, so inventory, there is no business logic. It always returns true if you ask if the item is in state. But in order, there is, in the order service, we are able to read an order by ID, which leverages right now Dapper SDK for Go. There's a Dapper SDK for .NET and for other languages, and says, "Hey, Dapper, give me the state from the orders state system with the following ID," or the corresponding implementation to create the order says Dapper save state. So in Acker, we just deploy our 3 containers, right? So there is the order, the facade, and the inventory. And the interesting thing is we specify the state component. We make it visible to a scope. And the scope is, in our case, where is it? Let me quickly find it. It's to the order service. And for all the container apps, we add the Dapper configurations. We say enable Dapper. My app runs on the following port. My app has the following name. That's the magical string that we use to do service invocation or to hand over service invocation to Dapper. And we say we want to use HTTP. So that has been deployed to Azure Container Apps already. I can invoke hello, which is just, giving back hello, simple echo. I can take an order. Let's say I want to order 500 times item with ID 122 and 30 times item with ID 83. And boom, we got an ID back. We can go to order again. We can check and we get the values back, right? So if we go to Azure, we can double check with Cosmos DB. We can go to the Data Explorer. Come on. Move on. There we go. So there's the orders DB. There's orders. There are items. And I think that's one. At least I hope. We can take the value, it's base64 encoded. We can go to the console and we can say echo that string and say base64-d, and we get back 500 times this item, 30 times this item, and the other ones were, way below here in the Postman request. Great. So as you saw, we can leverage Dapper to, build our distributed application architectures to build our microservice-based architecture, and we can get rid of technical implementation details like accessing Cosmos DB. It's just, the Dapper SDK or an HTTP or gRPC interface that we leverage. And in the container app, right now, we don't see the Dapper sidecars right here. However, what we see, and this is in the slides already mentioned, we can go to Azure Monitor or also go directly to Azure Log Analytics Workspace, and we can take a look at the logs. So by default, all containers that log to standard out and standard error, they will be scraped by Azure Container Apps, and the logs will be pushed towards the Log Analytics workspace. So if I, for example, want to see what happened on the Facade API, they enrich data with container app name, with the container IDs and stuff like that. But the interesting thing is I get everything that was written to standard out, in this case for Facade API or for the order API, or if I want to get the full picture, you can see that it's obviously my containers are logging over here, but we should also see, let's quickly grab the sec. There is the Dapper D container. They are also logging. So it's not just my log that's provided or created my standard output scraped from my container, also from the sidecar container that Microsoft injects to make this app a Dapperized application. All right. So I have one sample that is also quite interesting, I guess. Let me quickly destroy this one, and let me bring up the traffic split example. So let's say, it's the traffic split. I can demonstrate it. There is, so let's quickly catch up with the slides. So being interrupted in the stream before that bombed my flow a bit. So logs and metrics are pushed to Azure Monitor. To Log Analytics Workspace, we can query them using Azure Monitor or Azure Log Analytics Workspace, and we can take action on them. So there are metrics right now, but there will be more metrics once we hit GA. We were already diving through those. So the inner loop, AZ Container App, that's the command they released a week ago or so. Let's make a test. And let's touch the Docker file. Let's touch a Docker file. Let's open code. And let's bring in from Thorsten Hans /gopher. Let's bring in the hero, right? So we want the hero, expose 80. That's it. And right now, let's say AZ container app up. Oh, sorry, I missed two. Source dot current folder name, let's say live demo Akka. Let's give it a name. And what now happens? This command will spin up an ACR, will upload the code from the local folder, run a build to get a container image. Oh no, timeout. Let's test it again. It's preview. There we go. So it's reusing the container app environment instead of creating a new one. It's creating a new Azure Container Registry on the fly. It's uploading my code. Then ACR will download the code. That we'll see that in a second. It will build a container image on the fly. It will take that container image and deploy it to a new Azure Container App and give me the full qualified domain name to access my application. So right now it pushes the created Docker image to ACR. It's creating a live demo Akka inside of the existing resource group, and you can customize all of those, right? You can reuse an ACR instance instead of, again, spinning up a new one. And there we go. We can click the button, and let me quickly bring up Gopher over here, and we are up and running in a second. Not a second, in a minute or so. And this is, to be honest, this is an awesome inner loop story, right? This is how fast you can go from writing a Docker file to get your container executed in Azure Container Apps. So with that, once again, sorry for interrupting the stream. That was not intentionally. I hope you get an understanding of what Azure Container Apps is and what it can do for you. We saw, I think, a bunch of things. Most important thing, it's frictionless for single container, for microservices architectures. I think it's powerful enough for most organizations, for most workloads. Obviously, it's like always, right? It's an 80-20, 80% it works, 20% you have to use something else. It won't replace AKS or Azure Web App for containers. Definitely not. We are in preview. There's no SLA. You will already be charged for using Azure Container Apps. Keep that in mind. But there are some things missing due to the preview phase, right? Volume mounting, custom domains, key vault as a secret persistence, and so on and so forth. So check the roadmap to stay current with all the things Azure Container Apps. And with that, I have two links for you. The left-hand side, that's the GitHub repository. The right-hand side, that are articles I wrote about Azure Container Apps, explaining everything we saw and other additional capabilities from that service. So with that, if you have any further questions, don't hesitate, use the chat, reach out, or if, I know that if the question pops up in your mind in half an hour or so, either find me in the event platform or shoot me a tweet, send me a mail. So thank you for attending to my session. And with that, are there any questions in the chat? Quickly check. Custom domain support seems to be close and tracked. Yeah, good note by Simon in the chat. Custom domain support seems to be there. Yeah, and I recognized it in the bicep file because I was asking IntelliSense of what's possible in that particular configuration on that particular space, and it was custom domain section was there. So yeah, good. We can take another check mark. We got custom domain support. At least it looks so. And there is the issue with number 8 in the repo. Yeah. How do you handle your version control for the inline code there? API and bicep. Okay, that was just checking. So the inline code in the policy was. Okay. Sorry. Yeah. I see. Okay. So I think besides the custom domain questions, we are all set. There are no questions remaining. So once again, thank you for attending. If there are questions, just ask.